Okay, let's dive right in. If you're in academic research, you know that AI isn't some sci-fi thing anymore. It's here. It's your new lab partner, your new research assistant, and honestly, the source of some really tricky questions. So in this explainer, we're going to unpack that. Is AI the greatest tool we've ever been given, or is it maybe the biggest threat to research as we know it?
And if you want to understand just how fast this is all happening, get a load of this number. According to the latest AI Index report from Stanford, the cost of using top-tier AI models plummeted over 280 times in just 18 months. What was once ridiculously expensive is now basically pocket change. That puts an unbelievable amount of power into the hands of pretty much every researcher on the planet.
Which brings us right to the heart of it, doesn't it? Imagine you get a new colleague. They're an absolute genius, they work 24/7, and they cost next to nothing. Sounds amazing, right? But what if they also have some, let's just say, unpredictable habits? Can you really trust their work? Can you bet your career on their conclusions? Well, that's the exact spot researchers are in right now. So here's how we're going to break this all down. First, we'll look at the incredible things AI can do versus the real dangers it brings. Then we'll get practical and build a toolkit for how you'll probably be using AI in the very near future. After that, we are going to dive headfirst into the ethical minefield. And finally, we'll talk about what it actually means to be a researcher in this brand new world.
All right, let's kick things off with the big picture. The massive, massive opportunities and the equally massive risks. It is a classic double-edged sword.
On one side of the coin, you have AI as the friend. And we're not just talking about it getting a little bit better. The Stanford report makes it clear. These systems are consistently blowing past human expert performance on tasks that we thought were crazy difficult just a couple of years ago. We're talking superhuman, and it's happening right now.
And here's a perfect example of what that looks like. You're looking at something called the MMU benchmark, which is basically a huge college-level exam covering dozens of different subjects. And look at that. A model like OpenAI's GPT-4o is already scoring nearly 80%, getting really close to what human experts can do. This isn't just about doing things faster. It's about expert-level thinking on a massive scale.
And this superpower isn't just for general knowledge tests. In really specific scientific fields, the impact is, well, it's mind-blowing. We're seeing AI models that can design protein sequences better than we ever could in a wet lab. They're discovering brand new materials, new chemical reactions, and get this, some are even running entire biology labs completely on their own, from coming up with a hypothesis all the way to discovery. But here comes the turn. For every one of those incredible leaps, a big shadow follows. And this is the foe we're talking about. The ethical, the social, the scientific challenges that are actually patched later on. It's a fundamental part of how these things work, and we have to manage it. And this right here is the absolute heart of the problem. Because these AIs learn from us, from the giant ocean of text and data we've created. They don't just learn our knowledge. They learn all of our biases too, around race, gender, religion, you name it. The real danger isn't that AI is going to invent some new kind of prejudice. It's that it can perfectly capture our own messy, unconscious biases and then present them back to us as if they're objective, data-driven facts.
Okay, so let's move from the abstract and get really practical. How is a PhD student, or any researcher, actually going to be using these things in, say, 2026? Let's build out the essential toolkit.
First up, the literature review. The friend here is an AI that can read 50,000 papers in an afternoon and find a hidden thread connecting a study from 1982 to one from last week. That's a connection a human might never make. But the foe, is the dreaded hallucination. This is when the AI confidently just makes stuff up. It will invent entire studies, complete with fake authors and journals that look completely real, and a single one of those phantom citations can poison your entire research project. Tool number 2, data analysis. The friendly AI here is an absolute beast at finding that needle in a genomic haystack, spotting a super subtle genetic marker across millions of data points. The foe? It's an AI that has no clue about the difference between causation and just a random, meaningless correlation. Like linking ice cream sales to shark attacks. It will find patterns, absolutely, but it has zero real-world wisdom to know which patterns actually mean something and which are just noise.
And finally, writing and visualization.
AI assistants can be a lifesaver, helping a non-native English speaker write crystal clear sentences or turning a messy spreadsheet into a beautiful, ready-to-publish chart in seconds. A huge help. The risk, the foe, is a bit more subtle but profound. It completely blurs the line of authorship. Where does your thinking end and the AI's begin? And worse, it could lead to a future where all academic writing starts to sound the same, sanitized, uniform, and losing that spark of individual genius.
So you've got this powerful but very flawed toolkit. How in the world do you use it responsibly? This brings us to the ethical minefield and the critical skill of learning how to walk through it without, getting blown up. To get a handle on this, we have to realize that the word bias is actually pretty complicated. A really key report from the National Institute of Standards and Technology, NIST for short, points out that not all bias is created equal. And to fight it, you first have to know exactly what you're looking at. The NIST report breaks it down into 3 main categories, which is super helpful. First, there's systemic bias, which comes from the messy world that the data was collected from. Then you've got computational and statistical bias, which are flaws in the actual math and code. And finally, there's human bias. Yep, the errors in judgment made by us, the people building and using the AI. Let's just focus on that first one for a second, because it is so fundamental. Systemic bias is what happens when an AI, trained on data from our imperfect world, just learns to copy our historical mistakes. For example, if past hiring data shows a bias against women in engineering, an AI trained on that data will learn to be biased against women in engineering. It's not a bug, it's just a perfect reflection of the flawed data it was given. So here's the crucial takeaway. You cannot just code your way out of this problem. This quote from that NIST report says it all. The whole idea of techno-solutionism, thinking a smarter algorithm is the only answer, it's a dead end. We have to look at AI as part of a much bigger human system. Which leads us to our final section. Given everything we've seen, the incredible power, the real peril, the tangled ethics, what skills does a researcher need to not just survive, but actually thrive in this new age of AI? It really comes down to 3 key things. First, you have to develop true AI literacy. Don't just be a user who clicks buttons. You need to understand how the machine actually works and where it fails. Second, you have to actively use that ethical framework we talked about in every single step of your research. And third, and this is the big one, you must preserve human oversight. Your critical thinking is the ultimate safety net. The AI is your collaborator, not your replacement. This image captures that first point perfectly. There's a world of difference between just using AI tools and having genuine AI literacy. Literacy is that deep, fundamental understanding of how these things are built, how they can go wrong, and what the risks are. For any researcher today, that is absolutely a non-negotiable skill. And all of this leaves us with one final big question to think about. When an AI can do so much of the traditional work of research, the discovery, the analysis, even the writing, what does it actually mean to be a researcher? The future-proof researcher isn't the one who can do it all themselves anymore. It's the one who knows how to ask the right questions, who can critically tear apart the AI's answers, and who can steer this incredibly powerful new partner toward real, responsible discovery.